looking to sort of get the most bang for our buck. Now, when we're talking about graphing lines, if I show 2 points on the line, that has essentially set the scale for the graph. You're totally welcome to use graph paper if it helps you. You don't need to use graph paper, but in order to get full credit, I'm always going to want to see 2 points labeled on the line. I don't particularly care which 2 points unless I specify which 2 points. And if you look at some of the problems in the textbook, some of the problems are going to ask you to find the X and Y intercepts and to make that the 2 points that you label. I don't particularly care unless the instructions tell you otherwise. These instructions just saying we have to label 2 points. So if I said we had something like y equals -2x plus 5, and I'm about to go graph that, I'm going to give us some options for what we can do. So the first thing I'm going to say is that because it's in this slope intercept form, I can read off already that my slope is -2 and that my y-intercept, oh wait, I'm using the green and that doesn't show up so well. The y-intercept is 0, +5. Stop using the green, I'll put it over there. And this is the pen that likes to explode on me. I think I need to just throw it away. Let's try red. See how red does this morning. So if I have the y-intercept and the slope, and those are the tools that I wanted to use to graph this, then I'm going to go ahead, draw some axes for myself, and start by labeling the y-intercept. So I'm just going to put a point here, and I'm going to call it 0, 5. That's what I mean by labeling. You're going to put the point, and then give an ordered pair of the x-coordinate, the y-coordinate. That's what our label should look like. If my slope is -2, one option to graph this is to take this picture, draw a slope that is negative, meaning as I move from left to right, it should be going down. And one option would be to use the slope to label a second point. Another option, which I like better, would be to find the x-intercept. And the reason I like it better is that it's more universally something that we're going to do when we're sketching things. Started with my y-intercept, drew a slope that's appropriately negative, and now I'm going to find the x-intercept. So to find that x-intercept, that means that y should be 0. Because everywhere on the x-axis, my y values are 0. Relative to origin, we haven't gone up or down. We've only gone left or right. So if I take my equation and I plug in 0 for y, if 0 is equal to -2x plus 5, I can add 2x to both sides and then divide both sides by 2. And I would get 5/2. I can do a quick check to see, is that fraction in lowest terms? And it is. 5 is not divisible by 2. So I'm just going to label this point 5/2, 0. The two things that I can read off of this equation are the slope. I think this green shows up a little better, right? Yes. Okay. Are the slope, and I know that this passes through the point. (3, 12). So if I only need to label 2 points on the graph, I can just head straight into finding another point, and I can use 312 as one of the points on the graph. If you are at all nervous about potentially making an error with the minus signs, then I would say, don't worry about trying to read an extra point off the graph. Let's just find the X and Y intercepts, because that's going to work for nearly every problem we need to do. So if I go in for the X and Y intercepts happen when the X value is 0, and X intercepts happen when the Y value is 0. So I'm going to give you all a minute or two on your paper to try to come up with what the X and Y intercepts are after you plug in the appropriate value. So for that Y intercept, I'd have Y minus 3 is equal to 1/3 of 0 minus 12. I'm going to be trying to get the Y by itself. And when Y is 0, I'll have 0 minus 3 is equal to 1/3 of X minus 12. And we're trying to get the X by itself. If I come in here to find the Y-intercept and the X-intercept, I'll start with the Y-intercept, and I'm just going to simplify the right-hand side as much as I can first. And I talked through this with several of you. You can either think about this as 1/3 times -12 or as -12 divided by 3. You can think about it as multiplying those fractions straight across. However you want to get there, this is going to be -4. And then I can add 3 to both sides so that I end up with Y equals -1. Now, as a coordinate, that means it's the point 0, -1. On my X-intercept side, I'm looking at -3 is equal to 1/3 of X minus 12. Choices, I can distribute the 1/3 through, or I can multiply both sides by 3. They're both correct. So if you did it not the way I'm about to show you, just pause. And as long as you got the right answer in the end, don't worry about trying to change your work. I'm going to multiply both sides by 3. On the right-hand side, 3 times 1/3 is 1. So now I don't have to worry about that fraction anymore. On the left-hand side of my equation, 3 times -3, I've got -9. So now I'm at -9 is equal to X minus 12. I can add 12 to both sides, 12 to both sides, and have the X is equal to 3, which gives me a coordinate of 3, 0. And I think I've got space. I'll just squeeze my graph right in the middle here. Maybe my pen decides to cooperate today. So I need the point. This was my Y-intercept. So I should be at 0, -1. And since it's the Y-intercept, it should be down here at 0, -1. And then my X-intercept should be over here at 3, 0. And I'm going to go ahead and draw my line in and ask myself, hey, does it look like I have a positive slope because we were expecting a positive slope? Yep. Unlike the other two forms, I can't just immediately pull the slope out of this. I can't see it. I can do some math in my head to see it, but there's nowhere to just read it directly off of the equation. So I really have to go back to finding the X and Y intercepts. So if I want to find the Y intercept, that happens when X is equal to 0. If I want to find the X intercept, that happens when Y is equal to 0. Which I was expecting this one to be faster because this version of the equation of the line really does lend itself quickly to doing this. If I replace the x with a 0, what's 2 times 0? So I've got 2 times 0 plus 5y is equal to 20. That's gone. If 5y is equal to 20, what times 5 is equal to 20?
4.
Okay. Over here, if I replace my y with a 0, then I've got 2x plus 5 times 0 is equal to 20, which means 2x is equal to 20, and 2 times 10 is going to give me 20. I'm going to write both of those as a coordinate with my x value, comma, the y value. And over here, my x value is 0 and my y value is 4. By the way, another just kind of option for keeping track of plugging in points / something that you will be asked to do in the homework is to kind of organize these thoughts into a table. So if I make a table of the x values and the corresponding y values, when we plugged in 0 for x, the corresponding y value was 4. And when we plugged in 0 for y, the corresponding x value was 10. That time is dying on me, so let me try another one. 0, 4 for my y-intercept means I'm going up 4. And 10, 0 says I'm moving 10 to the right. And somehow I always manage to write my numbers exactly where I need my line to go, but good enough. Now, one option for this would be to go ahead and write the equation of the line first. And we practiced a bunch of that on Friday. And that would be a good thing to practice sometime if you wanted to. But this question didn't ask us for the equation of a line. It only asked us to sketch the line. So I'm just going to do that and I'm going to sketch the line. But I also know that to get full credit, I've got to show 2 points on the graph. And I've only given us 1. So I want to talk about how to use the slope to get a second point on the graph. I'm going to start at the point 5, 0, because that's the point that we know is on the graph. And if that slope is 2/3, then that tells me that my change in y should be 2 for a change in x of 3. To get to another point on the graph, that means I need to change my x value by 3. So take 1, 2, 3 steps, which means my x value would now be what? And I need to make a change of 2 in the y direction. So 1, 2. So I'm going to end up at this point over here where my change in y was 2 and my change in x was 3. So I'm now at 8, 2. Know that my point slope form needs to look like y minus y1 is equal to m times x minus x1. And the point we were given was 5, 0. 0 is the y value, so I'd have y minus 0. Our slope that we were given was 2/3. And the x value at the point was 5, and we can walk away. We are done. If you happen to do this in y equals mx plus b, then I think you should have gotten y is equal to 2/3 x minus 10/3. And I got this just by distributing the 2/3 in right there. So this is gonna be a two-part question. We're gonna sketch the line passing through 2,3 parallel to the x-axis. And then we're gonna find the equation of that line. And do the first part. So sketching the line that passes through the point 2,3. So there's a point on our line. We need 2,3. So I'll just call that here. There's 2,3. If we say that this line is parallel to the x-axis, that means that it has the same slope. So if this is the x-axis, then this line should be parallel to that and should look something like this. So I'm going to sketch in that line. But if we're going to get full credit, we for sure have to label another point on this graph. So I'm going to ask you to label this point right here. Yeah. I promise not to make you talk. Just stick your hand up if you know what we should label this point. Is anyone willing to tell me what they labeled this point? Yeah.
Is it 0,3?
People were thinking that it's probably 0,3. Since it's on the y-axis, it's definitely got that x value of 0. And if this is a flat line, the y value didn't change. So that is definitely 0,3. If we're going to find the equation of this line, it means that we need to know what the slope is. And now that I have 2 points, we can find the slope. Totally fine and appropriate, and I hope we are working towards you don't need to use an equation to find the slope of this particular line. Does anybody know what the slope's going to turn out to be? Ellie, is that it? So 1 is an excellent guess. This is actually going to be a slope of 0. Yep, totally. Anytime we have a horizontal line like that, the slope is going to work out to be 0. It's totally fine to plug the numbers into the formula. So if I have a change in y over a change in x, as I move between these 2 points, my y value didn't change. So that would be a 0 on top of that fraction. My denominator changes, right? My change in x here was 2. But if I have 0 divided by a number, it has to be equal to 0. Now, I don't want us to take that as like some magic fact, like when we had 2 raised to the 0 equal to 1. I don't want it to be a magic fact. So I do want to just take a quick second here to make sure we're good with y0 divided by 2 has to be equal to 0. Give me any 2 numbers under 10. And I need another one. 2? Okay, 7 and 2. Got it. So 7 times 2 is equal to 14. Is kind of another way of saying 7 is equal to 14 divided by 2. So if I started with something down here that looked like 0 divided by 2, and I wasn't sure what that was equal to? That's equivalent to saying something times 2 had to be equal to 0. Well, what's the only thing that when I multiply it by 2, I get 0 back? Right. So a number divided by 0, by definition, has to be equal to 0. Now, if it's the other way around, we're going to talk about what happens. So I'm going to take almost the same question, but this time we're going to sketch the line passing through 2, 3 parallel to the y-axis. Oh, hey, we never actually found the equation of the line. Oops. Okay. Pause. We need to actually finish answering the question. We can squeeze it in. So if we're going to find the equation of this line, I'll just give myself a little bit more space. So if I'm going to find the equation of this line, and I use the point slope form, we've got a slope of 0. And we know this point that it's passing through. So I would have y minus 3 is equal to 0 times x minus 2. What is 0 times some stuff? Right. So this would say y minus 3 is equal to 0, or another way to write that would be that y is equal to 3. And that is the equation of the line. If you find it moderately disturbing that the equation of a horizontal line is something that y equals and not something x equals, because it totally feels like it should be something x equals, it just isn't. Based on how we structure our equation of a line, a horizontal line is always going to have a y equals kind of equation. Okay, let's finish this one off. We're going to sketch the line passing through 2, 3 parallel to the y-axis this time, and then find the equation. And because I don't have a lot of time, I'm kind of going to do this for us. So first of all, the sketching the line part, let's get that part going. We're up here at 2, 3. And if I want to be parallel to the y-axis, that means I'm drawing a vertical line. So in order to have a second point on the line, I'm going to choose the x-intercept this time. And that x-intercept is going to look like 2, 0. To find the equation of the line, if I'm looking for those same two things, I'm looking for a point and a slope. The problem here is when I go to find this slope, which is a change in y over a change in x. Now I got another pen that's misbehaving on me. It's just not my day. I've got a change in y over a change in x. Our y value changed by 3, but our x value didn't change at all. We call this an infinite slope or an undefined slope. Now, if I use the same kind of logic we used before about changing this into an equivalent multiplication problem, if I have 3 divided by 0, and I'm not sure what that's supposed to be equal to, as a multiplication problem, that should say 3 is equal to 0 times something. Is there a number that I can multiply 0 by and get 3? That's why we call this undefined, because there isn't a number that will make this work. As a little preview of coming attractions for calculus, when we get a number divided by 0, we don't get to quit. We've got extra tools to deal with the number divided by 0. When I go to write the equation of this line, this is going to be x equals 2. Because everywhere on this line, the x coordinate is 2, regardless of what the y value is. So for a vertical line, my equation is going to look like x equals something.